All right, can everybody see that? You move you out of the way. Boom. Okay, can everyone see that? You may just give me a wave or something. Yeah. Okay. Good. 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 Okay. So this is a work that I've done at BLS, creating a ggplot package for doing seasonal adjustment graphics. And standard disclaimer: these views are those of the author and do not necessarily the views of BLS. So I'm going to talk for about 5 minutes. I'm going to talk for about 5 minutes, and then I'm going to go to the end because I'm a lightning talk, so I only have 7 minutes. So anyway, this is my outline. So I began working at BLS in 2019 as a hired annuitant, and I did a lot of work I'm doing a lot of work in R. Many of my colleagues only work in SAS, but I found myself with a whole bunch of packages and a whole bunch of routines. So I decided to teach myself how to generate R packages to help with this work. And the first R package I tried to develop was an R package for seasonal adjustment graphics. This was based on Tom Evans' blsplot SAS package that he put together. And I called it blsplotR. I used just base R plots. But back. Oh, come on. There we go. But gradually I became disenchanted with base R plots. I found that, I'd wait a couple of months, upgrade my version of R, and then all of a sudden the plots, all the margins would look wonky. I'd had to make a whole bunch of changes. And I wanted to create professional looking graphics with the least amount of time. So I decided to convert all the functions from blsplotR to use the ggplot2 package. Now, the ggplot2 package is a graphics package within R that was created by Hadley Wickham, and there's a reference there to the actual package. It's based on the book The Grammar of Graphics by Leland Wilkinson, which was published in 2005. It creates plots in layers. First, you manipulate your data into a data frame, and then you use that data to generate graphs, and you map the variables within the data frame into an aesthetic. Say one variable is the x-axis, one variable represents the y-axis, you do groupings, and et cetera, et cetera. Then you add a layer for the type of the plot. It can be a line plot or a point plot, a facet plot, an histogram, et cetera. And you can add attributes as you go along, like color, titles, and access labels. And ggplot returns what I like to call a ggplot2, a ggplot object. And this object itself generates the plot. The object itself is actually a list object, but when you basically expresses itself as a plot. So it's a very compact way of representing a plot. So here, these are the kinds of plots that I've developed. I've got about 30 plus plots within the BLS ggplot package. They're basically simple time series plots, factor plots, spectral plots, etc. I don't have time to go through everything. I'm going to basically stop at 5 minutes and finish up, but so this is just a way of specifying a time series plot, and it's kind of illustrative of how everything is structured. Usually I name things with plot underscore and then the type of plot. So here I'm just plotting a series. Air passengers is a built-in TS object, and I'm just going to plot this. I'm going to put a grid on the plot. I've got a title. I'm going to draw recession, shaded areas for the recession. The line's going to be dark blue. And I'm going to store this all within this air underscore P object within R. And then when I type air underscore P, it produces this plot. And so you see there's the blue line. Here's the lightly shaded. There's a light gray areas that show when NBER declared there was a recession. And so you can look at so this is just a simple plot of the air passengers. Now, not only can I do that, but I also work very much in conjunction with Christoph Sachs's seasonal package. So if I create a Cs object using the seasonal package, this plot underscore table allows me to print any table that's accessible within the Cs object. So I've saved. So here I'm going to plot the D11 table right here. The second argument here is the D11 table. So I'm just going to plot the seasonal adjustment. and I've got a main title, a subtitle. Here I'm drawing a recession, but I'm also adding the gray background. By default, ggplot allows you to it puts in a gray background on every plot. I don't quite like it, but some people do, so I allow you to either turn it on or off. Here you can add outlier, indications of an outlier, and here I specify the ggplot object, and here's the actual plot. Notice you've got a grid, you've got a gray background. Here are the lightly graded shadings of the recession, and this red line is an AO. So here, I'm going to go back. You can also, I'll do a couple more plots, and then I'll try to finish up. This is a factor plot. We used to call these in R, used to call these high resolution plots, but this is basically the combined adjustment factors. You can notice how they go up, the basic pattern. This is a ratio plot. You can plot just about any plot as a ratio. This is a quarterly series. It's the 3x5 seasonal factors for the UK gas series. You can also generate component plots. Here is the irregular trading day and holiday adjustments for the U.S. retail shoe series. Anybody that took a cost Census Bureau knows that we like to use the U.S. retail shoe sales. This is the seat seasonal adjustment. This is the seasonal factors and the irregulars from that in a component plot. This is created as a facet plot within ggplot. Now, you might say, well, you did a plot of the X11 factors and you did a plot of the seats factors. It might be nice to look at them together. And here you are. We have a whole bunch of stuff where you can do comparison plots between two different sets of factors. So here's the X11 seasonal factors for U.S. shoe sales. Here are the seat seasonal factors. Might be nice to see a direct indication of how they're different. And here is a third panel, which is the ratio of the seasonal factors between the X11. So you can see here, you've got about a 1% difference over here. And you can just take a look and see how they differ as they go along. You can also compare X11 and seat seasonal adjustments in just a line plot like this of the seasonal adjustments. Here I've included the original series in light gray. If I remove the original series, I can look at the details of the seasonal adjustments much easier. And also I can do a facet plot where I can look at them up and down. I tend to like to look at facet plots like this because I can track different differences. You can see here that the peaks in the X11 plots are somewhat sharper than they are in the seats. Anyway, yes, you can create seasonal subplots. This is the 3x5 subplot for the air passenger series. You can do it like this. And these are the seasonal subplots for the UK series. And there are some pretty simple plots. Here's a year-over-year plot of your air passengers. And this is a double spectrum plot. Here you have the blue line is the spectrum of the original series, and the green line is the spectrum of the seasonal adjustment series. And the red dots here, the red stars here, is peaks in the spectrum by the visual. Here you can see that there's actually a small peak here in the seasonal adjustment of the air passengers. So now I'm going to skip to the end here. I have a bunch of utility functions as well. This can extract information from a SEAS object generated from the seasonal package that I need to do annotation of different plots. But I also have this one package, this one function you might be interested in. I want to highlight the generate alt text function. In the US, we have an issue with we have to generate accessible documents, things that are accessible to people with limiting conditions, the blind and people with limited sight. And oftentimes you have to generate an alt text that you include in your documents for each of the different. And so this is a function that allows you to generate, at least to give you a basis for generating alt text. And I use two methods for doing this. There is a Braille R package that I learned about in a presentation at JSM by Carnegie Mellon. And this Braille R package is very helpful in creating R resources that are useful to the blind. And there's a VI function within Braille R that produces a list where one of the list object is an alt text for the whatever ggplot object that you give it. So if you have a ggplot object that's made either by my package or some other package or your own work, you can submit this ggplot package and generate alt text automatically. Now, I would say that this is often too granular for most purposes. because it's basically describing each layer. So the first layer, it's going to say, yeah, you got a title that's this, you've got subtext that's this, you've got a green line that's labeled as X11 and a blue line that's labeled as seats. But you know, it's a good start. And the reference I would give you is Godfrey 2023. The second method I use is inspired by an article by Amy Sazal called Writing Alt Text for Visualization. It suggests a rubric for generating alt text for plots. The user specifies the plot type, the type of data, and the reason for doing the plot. And there's a reference. It's in Nightingale, which is an article for it's a online journal for visual. So I'm going to show you an example of using Amy's method. This is an histogram that I included in my JSM talk. It just basically compares the distribution of p-values for different seasonal adjustment diagnostics. And so here, this is a function that basically you specify the chart type, the type of the data, and the reason. And the reason is it's important because what Braille R won't give you is why this plot is important, what the differences is. And here you can tell, why did I do this plot? Now, and I'm saying it shows the distribution of the diagnostics are heavy left tail. So that's a little short, but you know, for the purposes of this plot. And I say short alt equal true because I only want to output this short description of the alt text, and it will produce this alt text that you can then incorporate into your Word or PowerPoint document. I think this could be potentially very helpful for those of you who have to produce accessible documents. So finally, these are the references. I can make these slides available to you if you like. And I thank you all for listening to my somewhat longer lightning session. This is my contact information at BLS. All of these routines are on my GitLab. BC Monsell /BLSplot and capital GG. And I thank you for your attention. I will see. Let's go back to. I'll stop sharing and I will entertain questions. Well, if there are enough questions, I see Tim has his hand raised. Go ahead, Tim.
Yeah. Can I share something? I'm just wondering why people. So, for instance, I just generated a quick code in R.
Okay.
Do you see it?
Yes, I see it.
So I took the CO2 data, and if you create a seasonal plot using the data without the training, it takes time. So it's very difficult to see the seasonal cycle. So and on the other hand, if you add some even simple detraining method, even some simple moving average or something to remove the trend, it makes the seasonal cycle like much more visible and clear. And also in spectral plots. So so the basic example of GG season plot, for instance, is like this, without the trending, but it helps a lot, even if the method is not optimal. But you can choose, like, for instance, Friedman super smoother or some variant of STL with large enough, not STL, lowest with large enough window to remove it. It still would be helpful, I think.
Okay, thank you.
Just try to stop sharing. It's not appearing here. Just a second.
So are there any other questions or comments?
I have a question, Brian.
Go ahead, James.
Any use of like digraphs? So like are any of the options in there to make it dynamic graph, where you can?
Not yet.
Okay.
I'm
just curious.
One of the things I'd like to do is to collaborate with someone who's a lot better at things like Shiny and whatnot than I am, and start putting this in a framework where it could be more dynamic, or just put things in a reasonable, just put something in a Shiny framework.
Yeah, I haven't thought too much about how easy it is. I use digraphs a lot when, you know, comparing two series. Anytime you're comparing, it's nice to be able to have the ability to zoom quickly and, you know, scroll over and actually look at values. And I guess I don't know how easy it is to just take a static digraph and pipe it to a digraph. But that might be something quite nice. There's just something that popped into my mind as I was watching. If there was like one of the flags there was something like, you know, digraph true, false.
Yeah, no, like I said, I mean, this is sort of a pet project of mine. So, and I usually I develop new plots as I need them. You know, so I'm doing, I'm like, I got a new set of series and they're doing X11. I said, well, what do I, you know, I need to compare the X11 adjustments with the seats. So I create a function for that, put it in the package, and, you know, they generate hundreds of things comparing X11 and seats adjustments. So, you know, but yeah, I take the point, you know, it would be good to have something dynamic, but I'm, you know, there are only so many, many hours in the day.
My first question was going to be, where do I get it? So I see you have it on the last slide there. So I jotted it down. I will mess around a little, give you any feedback.
No, I'd be really happy to hear one of the things about preparing a talk like this, it's like, oh yeah, I should have added, you know, you come up with lists of things that, oh yeah, why didn't I do that? Why didn't I have why didn't I have a function to do this? And then you're like, well, I mean, I can do that using this function, but it would be nice to have a separate, you know, you start sitting around going, yeah, why didn't I do this? Why didn't I do that? You know, that's why it's always good to start trying to prepare stuff for stuff like this, you know, because you know, you get to see some of the holes and, you know, you're like, oh, that, you know, maybe that should be structured a little differently or whatnot.
Agreed. Thank you, though. That was nice.
Thank you. Okay, well, I mean, if there's no other questions, I will release you to the other session. Let me see what I need to see what the schedule is. Yeah, we're not quite at 10. Our session's supposed to end at 10, and the next session starts at 10:10. So the next session starts at 10:10. In this room, it's going to be seasonal breaks and official statistics. And in the main hall, it's going to be direct and indirect seasonal adjustment. So unless there are any more questions, feel free to leave or go to the other session, and we'll take like a 10-minute break